So in the previous video, we've talked about how to come up to this point in terms of Riccati differential equations, which is an advanced differential equations. And we have said that differential equations of Riccati is a non-linear differential equations reducible by either linear first order differential equations or by Bernoulli differential equations. And we have seen that to do that, you simply let the part that is the coefficient of y is squared, like we have rxy squared, to be equal to 0, such that it becomes a linear equation, because we know what makes an equation not non-linear is this power exponent 2. So when we have any equation that is being raised to power 2 or 3, is no longer a linear differential equation. So if we let the whole of this part rxy squared to be 0, it means that our equation becomes a linear first order ordinary differential equation. And when we do this, we are able to now reduce the Riccati differential equation to a linear first order differential equation. And we have as well seen that we can reduce a Riccati differential equations to a Bernoulli equations by allowing the rxy squared to be in the equations and simply let the linear part qx to be equal to 0. And once we have done that, we can now use the initial values of y and integrate the same function and proceed to find the general solution. And we know for us to find general solutions, you simply need the complementary functions, like you need the complementary solutions and the particular solutions. And once you are able to find your particular solution and your complementary solution, you are able to add them up and get your general solution for the given Riccati differential equations. So now let us now take a question. Let me shrink this as I proceed to give another questions regarding Riccati differential equation. This is just an explanation. So now let's see how we are able to solve a Riccati differential equations. Let's say I give you this question: solve. So I want you to solve So take the given differential equation. Solve the differential equation vy dx minus 2y squared plus 3y equal 1, where you are given the initial value y, the y1 of x, to be equal to 1. So what are we going to do? Let's have our solution. First of all, what we have in this case is dy dx. So we have dy dx to be minus 2y squared plus 3y. This is equal to 1. Again, we will have to make sure that we have represented this equation in the standard Riccati differential equation. The one I gave you before, we said that vy dx plus p of xy must be equal to rxy squared plus q of x. This is not in the standard form of a Riccati differential equations. So to do that, I will have dy dx. I will simply have plus 3y. This will be equal to, taking this negative 2y squared to the right hand side, it becomes positive 2y squared plus 1. So this equation that you can see here, this equation is in the same form like this given Riccati differential equation. So once you are able to do this, you proceed now to reduce the given differential equation to Riccati differential equation. So now let's reduce. We want to now reduce Riccati Riccati differential equation, DE. So we can do linear first order, so we can do the first order differential equations. So let's proceed and do that as we reduce this. Good. So we are told that to reduce this differential equation to first order, we need to use y to be equal to y1 plus 1 over z, or 1 over u. In this case, our y1 is simply equal to 1 as given here. We are given y1 as equal to 1. So our y therefore becomes 1. Instead of y1, we put our 1 plus 1 over z. 1 over z. And you know, 1 over z is nothing but z to the power of negative 1. So it becomes 1 plus z negative 1. So this here is what we are going to differentiate and find what is our dy dx. Let's go ahead and do that. So if I find dy dx of the function that we have, if I differentiate 1 by basic differentiation, it is simply 0. So this is equal to 0 when you differentiate 1. And when you differentiate z to the power 1, that becomes, so I will have plus, what I will have when I differentiate z power negative 1 is, I am going to bring the 1 down, so I have negative 1 multiplied by the derivative of z, which is z, then subtract negative 1 by 1, then that gives me negative 2. You know, you have to apply the product rule in terms of differentiation. I want to believe that you know what we mean by implicit differentiation. And since we are differentiating this in respect to x, but this is z, you simply have this as multiplied by dz over dx. dz over dx. So what is dz over dx in terms of this? This becomes our dy dx. dy dx will be equal to negative 1, because this side is simply 0, over z squared, because this is z power negative 2. If you bring it to the denominator, it becomes z squared. Multiply all this by dz over dx. And what is dz over dx? If I multiply by negative 1, it is simply going to give me negative z. I can still put it here. You have negative z prime. So this is negative z prime over z squared. So this is our differentiation in terms of 1 plus 1 over z. So you have this. The next thing we are going to do is to now put, you are going to put y and y prime. We put y and y prime in the Riccati differential equation. So if I put y, what is our y? Our y is negative z over z squared. The one we just got here, negative z over z squared. Plus, here we are going to have 3 because we want to put it in the Riccati differential equation. Plus 3y, and our y is negative z over z squared, right? Over z squared. So you have, if you can have this as simply 3z squared to make it easier for simplification. So I can have 3, in this case, 1 plus 1 over z, which is y, which is equals to 2y squared. So it is 2 and our y is 1 plus 1 over z squared. Then now go ahead and simplify this. Now you pay attention as you try to simplify this, because that is where drama will start. You have a negative z, we have our negative z, but the denominator is squared. So it is negative z over z squared. To remove this squared, we can square both sides. So we will simply have z squared, such that they will cancel each other. Plus we have 3. This becomes 3z squared plus 3 over z. So we will have it as 3 over z, 3 over z, then z squared, trying to square both sides. So this is equal to 2. So we have it as 2 into 1 plus 1 over z squared. So these 2 will go into the bracket. That becomes 1 plus 2 over z. 2 over z. I want to believe you still remember your binomial expansion. This is 2 over z squared. And then we will have, so this video is supposed to last for 15 minutes, so I will try to rush some parts. Let's expand this right hand side down here and see what we are going to have. So we have 2. So if I put everything outside and in the bigger bracket, I will simply have 2 into 1 plus 2 over z plus 1 over z squared in terms of squaring the whole bracket. So all this, we also have to square this as z squared, then plus 1, this one here, and we also square it, z squared. You need to take your time and go through this. Now let us now simplify this and see what we are going to have. So we are simply going to have here we have negative z over z squared. This simply becomes negative z squared plus because you see we are going to cancel out some things here. You will have z cancelling by z. So by simplification, this is what you will have. After we cancel out z squared by z, we will simply simplify the whole of this. We will have negative z prime plus 3z squared in terms of these plus 3z is equals to, if I open up the whole of this bracket in terms of 2 into 1 gives me 2, so I will have 2 into z squared, because all these are being squared by z squared, plus 2z plus 1, then plus z squared. Now cancelling out what is repeated, we will have negative z prime minus z equal to 2, which implies that our linear first order ordinary differential equation is z prime plus z to be equal to negative 2. So this is our linear first order differential equation. Now we'll go ahead after getting this to now find the integrating factor and find the general solution of the Riccati differential equation. Integrating factor, we will have y is equals to 1 plus 1 over c exponential negative x minus 2. Go through it so that you know what it has happened here, because I only wanted the video to be 15 minutes.